Okay, this is a key for the chemistry throwback week number 2, which is on the classification of matter. In order to do this assignment, you kind of have to understand the 4 different classifications of matter that we're going to be using in here. The first one is an element. An element is the purest kind of substance. What it is it's just atoms that are all alike one another. And so if you have an element, basically what that means, there's going to be some different things that indicate that you're dealing with an element. One of those things is that it will be on the periodic table. All right, so you know if it's on the periodic table, it's the element, is an element. The periodic table, the long name for it is the periodic table of the elements, so that should help you out with that. The other thing is, if you're looking at a formula and it has just one capital letter in it, like Ca or O or Mn, all right, all of those things are elements because they have, just one capital letter in them. They're just one individual substance. The next thing is called a compound. A compound is when we have atoms of different elements that are bound together, but they're bound together into a pure substance, so not a mixture of multiple different substances. So this is still a pure substance. Which combines elements. And the big clue here that you're dealing with a compound is that you're going to have a formula, and it's going to have multiple capital letters in it, or multiple different elements. So like CH4 is methane, all right, CO2 is carbon dioxide. We've got like NH3 is ammonia. Those are all examples of different compounds. Going down to heterogeneous mixtures here. A heterogeneous mixture, hetero means different. Okay, so a heterogeneous mixture is a mixture that's different throughout. Homo means the same, so homogeneous mixture means it's the same throughout. And so when you think about these things, first of all, a mixture means it's not going to have a simple formula. There's going to be multiple substances mixed together. And then heterogeneous and homogeneous has to do with like how well they're mixed. So homogeneous, every different piece of it will look the same. Heterogeneous, it will have little bits that look different than other little bits. And then one thing here, now you're going to have things that are heterogeneous mixtures, obviously, like say, if you had a trail mix or something like that, where it was a bunch of different looking things in there, heterogeneous mixture clearly. And homogeneous mixture, if you have something like, say, Kool-Aid is a common example for a homogeneous mixture. You mix a bunch of things together, you stir it well, all of the different pieces look the same, and so homogeneous mixtures will look all the same throughout. There are a couple special classes of substances that fit in here, though. So one of those is alloys. Alloys are mixtures of metal. So what you do when you make an alloy is you melt down 2 metals and you mix them together. And so they are mixtures. Alloys are mixtures. But if you do a good job at mixing these 2 metals together, then it's going to be the same throughout. So alloys fit here. Under homogeneous mixtures. For heterogeneous mixtures, we have a special type of substance called a colloid. What a colloid is it's a substance where you've got a liquid or something where there is little globs of some substance kind of dispersed throughout. So in the case of milk, the little globs are little globs of fat, and they're distributed around and they're suspended in there so that like they don't sink to the bottom, but it's also not purely homogeneous. If you look at it on the microscopic level, you can find these little globs of fat. So colloids are heterogeneous mixtures. Alloys are homogeneous mixtures. So going through and looking at this list, distilled water, this is pure water. It gives us a formula H2O there. So if we have a formula, we know that it's probably a compound. This next one, it says gold, and then it gives us here AU as the symbol there. So that's just one capital letter, and you can find it on the periodic table. That means it's an element. Bronze is an alloy. We just talked about alloys and said that those are a type of homogeneous mixture. Looking at air inside of a small room. So air is made up of multiple different things. It's made up of different gases, so oxygen and nitrogen, carbon dioxide, argon, a bunch of different gases mixed together inside of the air. So if we have a small room, we're going to assume that that air is relatively uniform. So when it's mixed together, we think that it should be sort of the same throughout in a small room. And if that's the case, we would also call this a homogeneous mixture. Sand and seashells on a beach, okay, those ones are going to be mixed together in a way where it's not the same throughout. Clearly, they're not going to be the same substances. So in this case, we have a heterogeneous mixture. Sand itself would actually probably be heterogeneous because it has different types of rock and things like that in there. So, you know, the sand by itself would probably be heterogeneous. But if you put in the shells, the seashells, it's definitely different. Okay, titanium. Again, we've got a chemical symbol here. It's just one capital letter. It's on the periodic table, so that's an element. Ammonia, which is NH3. We've got here a formula for that, multiple elements in it. That makes it a compound. Pure substance, but multiple elements. Not a mixture. Tap water. Okay, so tap water as opposed to our distilled water. Tap water has things in it, calcium, they add fluoride to it, things like that. So there are chemicals in there in addition to the water, but it should be sort of the same throughout. You kind of expect every time you go turn on your faucet that the same type of water comes out and is mixed well. So this one would be homogeneous, a homogeneous mixture. For the next one, it says plain vanilla ice cream, but then it tells you that ice cream is a colloid. So it being a colloid means that it's heterogeneous. The next one, also ice cream, so you could assume probably that this is going to be heterogeneous, but it says it's chocolate chunk, so that even like furthers the fact, you know, pounds it in that it's heterogeneous because we've got chunks of chocolate in with the ice cream. So that would definitely be different throughout. So it's heterogeneous. Salt NaCl, we have a formula there. So that tells me that it is a compound. Sterling silver is an alloy. Alloys are homogeneous mixtures of metals. The next one, mayonnaise, it says is a colloid, so that makes it heterogeneous. And then crystal quartz, or quartz crystal, it says here SiO2 is the formula, so that's going to be a compound. And then lastly here, zinc metal, it gives us here the symbol for zinc is Zn, so just one capital letter, so that means it is an element. Okay, that is that. Make sure if you have any questions on that, that you come see me and ask me.